So this question doesn't have a lot of words to it, but can throw a few people off. So let's read through it and figure out what we're doing. It says the displacement of a string is given by y of x and t is equal to y times the sine of kx plus omega t. The wavelength of this wave is what? Well, we know that this graph is of a sine function, and the sine function is just going to oscillate back and forth. We can actually even do a couple things more. We know that it goes between upper ym and a negative ym because sine function goes between -1 to 1. So we just multiply the max and the minimums from it. We also know it starts at 0 because it's a sine function. So this question asks, what is the wavelength? Well, the wavelength, if I were to look at position, our x position, and our y graph, so what the sine function looks like in reference to x and the y variable, forgetting about the t right now because time will progress, so this will be at time equals 0. We want to know what the wavelength is, and the wavelength is defined as when does this graph repeat itself. So I know that if I were to start at 0 and go all the way over to here, that this is equal to 1 wavelength. So at this point right here, it's x is equal to lambda. And this is how we're going to actually solve our question. Is we're going to say that at 1 wavelength, x has to be equal to lambda. And we know that the sine function repeats every 2 pi. So every 2 pi, we're going to repeat ourselves for this trig function. This is the argument of this. This is, actually I should probably put sine of x repeats itself every 2 pi for x is equal to every 2 pi. So we're going to repeat ourselves every 2 pi. So what I'm saying is that this argument right here, this inside the sine function, so in this case, kx has to be equal to 2 pi if x is equal to lambda. So if I substitute this in, I get k times lambda is equal to 2 pi, or lambda is equal to 2 pi over k. So lambda is equal to 2 pi over k. Answer choice that I have marked down, D, is the right answer. So all I had to do is figure out when does the sine function repeat itself. It's when the argument is equal to 2 pi, and our argument repeats itself every wavelength.